High SWR or standing wave ratio is a common frustration when setting up or maintaining an antenna system. It indicates that power is being reflected back to the transmitter rather than being radiated into the air, which can reduce efficiency and potentially damage your equipment. Modern radios also cut down the output when the SWR is high for safety. Here are 5 common mistakes that lead to high SWR and how to fix them. Incorrect element length. The most frequent cause of high SWR is an antenna that is not resonant at the desired frequency. If the antenna is too long or too short for the frequency you are using, the impedance will not match your feed line. Use a standard formula to get a starting length. Then use an antenna analyzer to find where the SWR is lowest. If the lowest SWR is at a frequency lower than intended, the antenna is too long and needs trimming. Trimming need not be physical trimming. You can also fold back the antenna elements. Then it will be easier to increase if needed. If it is at a higher frequency, the antenna is too short and needs lengthening. That is why we always start a little bit longer and fold back rather than extending, because extending is more difficult because you have to add extra wire length and there will be one joint extra. Second, poor choice of installation height or environment. You may not always have a control over that. Antennas do not exist in a vacuum. Proximity to the ground, metal roofs, gutters, or even thick tree branches can detune an antenna, shifting its resonance and raising SWR. Mount the antenna as high as possible and as clear of obstructions as possible. For horizontal dipoles, a height of at least a quarter wavelength above the ground is ideal. That may not be practical at lower bands. If you must mount near metal, try to keep the antenna at 90 degrees angle to the metal object, or increase the distance to at least several feet. 3. Coaxial cable and connector issues. Water ingress into the coax, a pinched cable, or poorly soldered PL259 connector can cause impedance mismatches. Moisture inside the dielectric of the cable is a silent killer of SWR. I had the problem. Water ingress after heavy rains damaged my expensive RG213 cable, and my friend recently told me that his RG213 cable was damaged by rodents. The whole outer sheath and even the braid was removed for a section by the rodents gnawing at them. Inspect your coax for kinks or sharp bends. Use a multimeter to check for continuity and ensure there isn't a short between center conductor and the shield. Always use high quality weatherproofing like a self-amalgamating tape on all outdoor connections. Currently I am using that because I have learned it the hard way. Lack of a balun or common mode chokes. When connecting unbalanced coax to a balanced antenna like a dipole, RF can travel back down the outside of the coaxial shield. This common mode current makes the feed line part of the antenna system, which ruins the SWR and causes RF interference in your shack. Install a 1:1 current balun or an ugly balun, an air core choke made of coiled coax itself, at the feed point. This forces the current to stay on the antenna elements and stabilizes the SWR. Improper grounding or counterpoise. For unbalanced antennas like verticals or NFEDs, the antenna is only half of the system. Without a proper ground plane or counterpoise, the antenna cannot push against anything to radiate effectively. If using a vertical antenna, ensure you have an adequate radial system, wires spread out on or just under the ground. For NFED half-wave antennas, ensuring the transformer is properly grounded or using a small counterpoise wire can significantly drop a stubborn SWR. I had this problem when I was using unfed half-wave antenna earlier. Now I am not using that antenna. I have never tried verticals because my location doesn't permit a vertical antenna.